Hey guys. So in a previous video, we talked about finding the circumference of a circle. And we talked about this at length. So a big thing we came to the conclusion of was that a circumference, so our length around the circle, that's important to define this. Circumference is the border length of my circle. It's kind of like the perimeter, but just for circles. It's the perimeter for rounded edges. So our circumference was either 2 pi r or pi times the diameter. Both work. Now, in this question, however, we're going to take this one step further because we don't always have full circles. We see a few different types of versions of circles, and they have a different outer length, a different circumference. So this particular thing we're going to be talking about today is called arc length. And what this means is we're looking at a portion of the circle. So let's quickly just redefine a few key ideas here. So the middle of a circle to one bit on the border is just going to be my radius. That we should hopefully remember from last time. Going from one side to the other side of a circle, that's called my diameter, passing through the middle, going from one end to the other. And the circumference is my entire outside bit of my circle. So going all the way around here. Now, what an arc is, or what an arc length is that when we cut out bits of my circle, so when I take, for example, this bit, let's consider this little chunk here. It's like a little pizza slice, right? Think of a circular thing. When you have pizza with your family or some friends, right? You're going to have the entire pizza. When you cut it up into portions, you have these little slices happening. And this particular length on the outside from one end of the slice to the other, this is what we call our arc length. It's the length of what we call an arc, just a portional outside bit of my circle. So if I were to actually draw this little pizza slice down the bottom here, that's going to look something like this. And my arc length is this bad boy over here, the outside bit. So here to here. And we're going to use this idea of arc length being a portion of the circumference. That may give you a hint as to where we might be going with this. We're going to use that idea and apply this to a couple of questions. Now, we already know how to find the length of a circumference. So what I want to do in my first question here is I want to find the length of the arc here. Whoops. I want to find, with a diameter of 25 centimeters, I want to find my arc length, the length here. Now, what type of circle does this look like? Well, this to me looks like a semicircle. It looks like half a circle. So what portion do you think of the circumference does this arc make up? Well, it actually makes up half of it. Because if we draw an entire circle, cut it in half, I have a whole circumference around here, but only half of it is present in this photo that I've drawn. So if I wanted to find that arc length, well, I'm going to have to find the circumference, and I'm going to have to halve that. So how do I find my circumference? Well, my circumference is pi times the diameter, because I'm given a diameter of 25 here. So my arc length here, is going to be just half of my circumference, which is half times my circumference, see? Or I can write that as pi times d. So half times pi times the diameter. Now all I have to do is just substitute pi and my diameter. And my diameter is 25 here. And that's in centimeters. And once I put that into my calculator, I'm going to find the length of half of this circle, which is going to give me my arc length here. So half times pi times 25 to one decimal place, that's going to give me 39.3 centimeters. That is a half portion of my entire semicircle here. Now, let's look at another example. Let's look at this thing here. I've drawn this particular thing, and I have 90 degrees as my angle here. Now, let me just center this just so I can show you guys something. Well, not really center it, but shift it along to the side. What portion of a whole circle does this look like? Well, if I draw out my circle, I get half of one here. Well, this makes a half a circle. And drawing this all the way around, I get a full circle. And as you may have guessed when I talk about portions, we're talking about fractions here. You can see we used it here. We used half. We looked at a portion of the whole circle, of the whole circumference, more specifically. That's what we're looking at here. So what portion of my circle do I have here? Well, I can pretty easily see, hopefully, that I have split this up into quarters. So my little pizza slice here, that chunk of the whole I've taken out 1/4 of the whole. And that's going to help us, right? Because also I should probably label one of these bits so you can see, so we can actually do the question. I have a radius of 8 centimeters. And now I can just find my arc length, this thing here, by first finding my entire circumference and then taking 1/4 of that to find my arc length in question here. So my circumference, I know the formula for that. That's going to be, because I'm given a radius here, let's write that as 2 pi r. And I'm going to take my arc length, let's call that AL, is going to be 1/4 of 2 pi r, or 2 pi r divided by 4. We can do this in the same way, but I'm just going to multiply it by 1/4. I'm taking 1/4 lots of 2 pi r. And now all I need to do is just substitute in my values. Well, I have 8 here. And what's that? Well, that's my radius. It stretches from the middle to an outer bit on the circle, on the border of the circle. So I'm going to substitute that into my radius here. And I get left with a quarter times 2 times pi times 8 centimeters. And what do I get left with? Well, let's pop that into my calculator. If I times a quarter by 2 by pi by 8, doing this to 2 decimal places, that gives me 12.57 centimeters. That is how we can find portions of my circumference. That's what we know as our arc length. It's a fraction of the whole circumference. It is a portion of a whole circle. We know how to find the circumference of a whole circle. So finding a portion of that, well, we just need to determine what fraction of it is exactly. We can see here it's a quarter. Now, just quickly, why is this a quarter? Well, all of these angles here, so this one here, if I have a straight line, I have a 90-degree angle. So using what I know from geometry, this is also going to be a 90-degree angle. And I have another pair of angles on a straight line down here and here. So I have 4 right angles. So 90 plus 90 plus 90 plus 90. I want anytime I make these angles, I have the angle of a revolution, 360 degrees. All of these angles have to make up 360 degrees. And 90 degrees is actually a quarter of 360. Let's just quickly look at that. Now, the fraction here is I have 90 degrees on my little pizza slice that I've cut out. So 90 out of 360, well, I can make an equivalent fraction here just by dividing the top and bottom by a number that goes into both. Well, 90 goes into 90 one time, and 90 goes into 360 4 times. So my equivalent fraction is going to be a quarter here. Now we'll hold on to this thought because I'm going to do this in another question. This is our final question of the day. Question 3. Now this is going to be slightly harder. This is the hardest question of the day that we're doing. I want us to find, I have 2 centimeters and I have an angle of 45 degrees. Here, I want to not only find the arc length, I want to find the perimeter, the entire border around my shape to here to here. I want to find all of that in total. So I have to consider these two as well, not just my arc length. But we'll start with the arc length because that's the hardest one. We'll do that, the hardest bit first. Now here we can see 45 degrees have been taken out of my whole circle. So this thing here, let's just rearrange this a bit. If I consider this particular thing here, I can think of this as a portion of a whole circle. I know it's a poorly drawn circle, but by considering this, I can now think of how I could set up this fraction. What 45 would be as a fraction of 360 degrees. The revolution. So if you remember from earlier geometry, a revolution is 360 degrees. And all these circular angles, they add up to 360 degrees. So what I'm going to do is I'm going to find my regular arc length by doing 2 times pi times my radius. Now, what's my radius here? Well, it is 2 centimeters. So I'm going to pop that in there. But what portion of this whole am I taking out? Well, the portion that I'm taking out, let's do this in a darker color. The portion is my 45 degrees out of a possible 360 degrees. That is the portion of my whole that I'm trying to find here. So once I've established this, I can just say, all right, my arc length equals 2 times pi times my radius is 2 times 45 over 360. Because I'm taking into account my circumference here. Circumference. As well as my portion. Let me label that too. So my circumference, and then I'm taking a portion of my circumference. So I'm multiplying my circumference by the fraction that's being given here. And if I pop this into my calculator, let's see what I wind up with for my arc length. Well, 2 times 2 gives me 4 times pi times 45 over 360. And that gives me an arc length to 2 decimal places of 1.57 centimeters. Now, are we finished here? Well, no, because our question asked me to find the perimeter. Whoops. It asked us to find the perimeter. So I found the arc length, and the rest of the perimeter is going to be this thing here and this thing here. Now, do we know the length of this side? It's not labeled on there, but this is just a length that stretches from the middle of the circle out to the border. So that's the radius. That's the same as my 2 here. So let's label that in 2 centimeters. And my arc length that I found was 1.57 centimeters. All I have to do for a perimeter now is to just add the borders. So my perimeter is going to be my arc length, 1.57 centimeters, plus 2 centimeters, one of my radiuses, and another 2 centimeters. And when I add all of that, I'm going to get 5.57 centimeters. Now, this is kind of like a harder extension question. It's a little bit of a trick question because we've been looking for arc length here. So a lot of people would have kind of just stopped here. But we need to read the question and just double check. We are finding the entire perimeter, the entire border around this little pizza slice, this portion of my whole. So that's how we can apply these portions to my circumference in order to find the arc length of a circle. Thank you so much for watching, guys. I'll see you in the next video.